Hello and welcome back to the second video on our introduction to agent-based modeling using Julia. And in this video, you will hear about the basics of modeling modeling agent-based models or realizing agent-based models using Julia, and a short introduction. This includes a very short introduction into Julia. So if you're already familiar with Julia, you can skip these parts or run them in twice as fast. Just to make sure that everyone is on the same page, we have a very short review of how to use Julia. But first of all, why do we want to use Julia? So in agent-based modeling, as we've already seen in the last video, we have to run simulations, and often we have to run multiple of these simulations. So it is important that we use a tool that allows us to do this. Obviously, there's multiple tools that allow this. NetLogo is one of them, and NetLogo is possibly one of the most famous ones. But we decided to pick Julia for some reasons that we think you hopefully will like as well and agree with as well. So Julia is a programming language that is very easy to program. I would say the syntax is very similar to Python, and you can also run it in a Jupyter notebook. And the name Jupyter notebook, the GU, is from Julia and the PY is from Python. And so if you're familiar with using Python in a Jupyter notebook, you can very easily adapt to running Julia in a notebook. In our case, we'll be running it as a program, standalone program, not from a Jupyter notebook, but you can very easily adapt it to a Jupyter notebook. Julia has very simple matrix operations. It's very similar to MATLAB. So if you're experienced in running MATLAB, you will find yourself right at home if you're trying out Julia the first time. One of the benefits of Julia is that it's very fast. The runtime is almost the same as C, so it is one of the fastest programming languages there is, in the same region as Rust, C, C++, and so on. And because we decided to pick Julia as our programming language, we need a library to do agent-based modeling that is compatible with Julia. And in this case, there is one library that's called Agents.jl. Libraries in Julia always have this .jl extension, and that's how you recognize a library to be a Julia library. The benefit of Agents.jl is that it's relatively easy to generate models, or it's not as easy as it is in NetLogo, but these models then can run very fast. So it's easy to extend a very simple model to a very large simulation because you have access to the full ecosystem of Julia. And in NetLogo, you are kind of limited by the tools that are available to NetLogo, although the extension system there now also allows a lot of different implementations. One of the key benefits of NetLogo used to be that you would instantly have visualization support and interactive experimentation, but that is now also available in Agents.jl, and you can do almost everything that you can do in NetLogo, you can also do in Agents.jl and more. And if you're a computer scientist and you have tried to learn NetLogo, you might feel the same as I did when I tried learning it. Since it is based on the Logo language, which is a programming language designed to be easy to learn for children, you found yourself maybe in a state where you were wondering, why is it solved like this and not as in other programming languages? And I found it very hard to wrap my head around Logo and NetLogo, and I really prefer a classical programming interface, which you can have using Julia. So maybe one of the benefits can be you don't have to learn NetLogo because you can stay in a comfortable environment of regular programming languages. Why would you not want to use Agents.jl? If you're prototyping and like doing very, very basic experiments, NetLogo is a lot faster in exploring these basic ideas. And it is faster because it's all graphical user interface, and the user interface fosters quick experimentation. But you still need to code a little bit, so you still have to learn NetLogo, and then you have to maintain two languages in your head, and I guess that's okay for many cases. But in Agents.jl or in Julia, you have the advantage that you can do everything that's available in NetLogo and all the other types of simulations, and you can even do a handwritten simulation as we've done in our Julia pre-course for this course. Often performance is not a critical issue in simulation. So if you're trying to understand effects, in very predictable environments. Even if they're complex and you need agent-based modeling, you do not often run into performance issues. And if you don't, you can basically run NetLogo on very large machines as well. The only problem is when speed is an issue, when you need results fast and you need a lot of models, then it can occur that NetLogo is not as fast as Julia, and it's by an order of magnitude faster, so you can increase your compute time by the factor of 10. And we will see this in this comparison. This is a reference benchmark used from the Julia website, by the way, to show how very simple tasks here on the right-hand side, how they perform in different languages in idiomatic implementations. Idiomatic means it's written in a way that's supposed to be written in that programming language, because obviously if you code inefficiently, you can write a very bad benchmark. So these are execution times relative to the C language. So C is always on level 1, so 10 to the power of 0 is 1. And you have every column is a different programming language. And you can see that Julia is in the range of C. Not every task is as fast as C, but some, for in this case, printing to a file is even faster in Julia, or user function Mandelbrot set is faster, but some are a little bit slower, like matrix statistics and parsing of integers. The Lua just-in-time compiler is equally fast. Go is equally fast, except for matrix statistics. That doesn't really work in Go. Fortran is relatively fast. And you see for here, for example, that Java is also relatively fast, but some of the features are 10 times slower than they are in C. So for example, printing to a file takes 10 times the amount of processing time. JavaScript is also all over the place. MATLAB, some of the functions, parsing of integers takes 100 times more than in C. And if you go to programming languages that are frequently used, such as Python or R, you will see that some of them are even thousands times slower than the implementations in C, especially if you do things that the language is not designed for, such as recursion. So calculating the Fibonacci numbers using recursion is very slow in R, and it's also very slow in Octave. So there is a lot of information in here, but the key information is Julia is relatively fast, and the things that are slower, they're just a little bit slower than C. So you could, in this case, say, why not go with Lua or Java? These are all fine languages. One of the reasons is that execution speed is not everything. You also want the language of the code to be easy to understand. And one measure for code complexity is the length of the code. The more code you have to read, the harder it becomes to retain all of that in memory, in your brain's memory. And in this case, Julia is a language that is as concise as languages such as R, Octave, Python, or MATLAB. Well, it's even more concise. It even uses less space than R, Python, and Octave, but it's orders of magnitudes faster than these languages. It is other languages that are on the same level of execution speed. They are all a lot larger, the code that you have to write to achieve the same result. Lua seems like also a very interesting option here, but it's not typically used for agent-based modeling. So Julia kind of provides the benefit of being both fast and relatively easy to read and having very small code complexity. And obviously these graphs are maintained, and there might be some improvement for Python for the next version here, because Python is also moving to a compiled version in the future, and so the differences here might reduce over time. But a benefit of Julia is that you can integrate it with Python, and we'll see that on the next slide. So there are some central ideas in Julia. One idea is that metaprogramming is made easy. We've seen this in the pre-course for the Julia tutorial, the @time macro, for example. It's a way of instructing code to be manipulated by code, so you can program on a higher level. And the @time macro kind of measures how much time a function call requires, and it does this by adding code to the code that you're where you're putting this in front. of, and you can apply this to any type of code. So metaprogramming is really easy in Julia, really as easy as metaprogramming is, and that is one of the core benefits in Julia. Another idea is that we do not have a two-language problem. If you're familiar with R and R package development, you will know that you will often run into execution time bottlenecks. And if that happens, you typically use RCPP to then write your time-critical code in C++, and then have kind of like a user interface in R, and under the hood, you're running C++. That is not the case in Julia. In Julia, all the libraries are written in Julia, and there is no glue code or hot code that combines these two languages with one another. So if you experience a bug in your library that you're using, you can very easily go into that code and try to fix it yourself, because if you know Julia, you will then understand the library's code as well. It's very easy to find errors in libraries in Julia if there are any. Obviously, it's free to use. It uses the MIT license, if I'm not mistaken, so you can use it commercially, you can use it in open source projects, and there are hardly any limitations to that. And it integrates well with other languages. You can natively call Fortran code, you can natively call C++ code, you can natively call Python functions. So you can basically load a Python library and then just call the functions of that library on your Julia objects, and that works completely out of the box. There is a library to include R so that you can transparently load an R session inside Julia, and after that you can even call your favorite ggplot function directly from Julia. And the same is true for Java. So if you're a fan of the Java world, you can transparently load your Java virtual machine inside of Julia and have some Java code that you want to call from Julia and run that inside of Julia and use the results from there in your Julia session. Another central idea in Julia is that the performance is achieved by dynamically compiling to optimize native machine code, which means if you run Julia, it compiles your code to something that is specific to your machine. So it is optimized to your computer as soon as you run it. This takes a while in the beginning, but overall this is what causes the dramatic performance increases compared to other tools that do not use local compilation. It is designed to be scalable, so there is different ways of parallelism that can be included. So we have SIMDs, single instruction, multiple data, so where you can run the same operation on multiple data at the same time, which is a function of modern CPUs, but you can also do stuff like threading, where you can put tasks on individual threads on your CPU that will deal with the task and then return the result to you. But you can also very easily introduce distributed computing by using macros, by the way, so that you can run it on a compute cluster on multiple nodes and distribute your simulations across a very large cluster without introducing a lot of overhead. The language is designed in a very modern way, and that is we move away from object orientation in favor of multiple dispatch, which tries to achieve similar things as object orientation, but does more than object orientation by making sure that, it's hard to understand, to explain multiple dispatch in a few seconds, but the key benefit of multiple dispatch is that your libraries that you use, they will just work with one another. You do not have a lot of compatibility issues. I will link to a video that will explain the benefits of multiple dispatch in more detail. Metaprogramming, as we've already seen, and also it's a very efficient type system that is used under the hood. As mentioned before, it uses the MIT license, so it's corporate use friendly, and the whole package ecosystem in most cases is also using the MIT license, which allows you to use it in corporate settings as well. So as I've just mentioned, Julia is not object-oriented. Julia uses something that is called multiple dispatch. And if you're familiar with object orientation, this will be easy to follow. If not, this is not really important for you, because you will not struggle with it, because it's relatively intuitive. And unless you're expecting object-oriented behavior, you do not have any problems with it. The idea of multiple dispatch is that the methods, the functions that you call on your data objects, are not part of the so-called class hierarchy. In object-oriented languages, you save the functions along with the data type definition. And we don't do this in Julia, except that methods live in the global or in a modular space. And we only have a data type hierarchy instead of the classes. So classes in the object-oriented language mean that there's functions plus data. And in our case, we only have data as a form of hierarchy. And the benefit of this is that since methods are only part of the module scope, we can resolve which method to call. So in object orientation, we would call this polymorphism, using the signature of the function. So we can define the function for a specific data type, and then that method is automatically being called if you're using the method with that data type, but it's not hard linked. And the benefit of that is that we can replace functions outside of the object hierarchy with our own functions, and we can add our own functions outside of the object hierarchy. And this is what introduces composability for free. And the link that you see here is the link to a very detailed explanation of multiple dispatch held at JuliaCon, I think from 2 or 3 years ago. And that video is really helpful in understanding multiple dispatch. But unless you are a little bit experienced in object orientation or programming in Julia, it doesn't really make a lot of sense to see this. So if you're really new to Julia, I would skip this here entirely and just trust me that multiple dispatch is a very sensible way to organize programming in a language such as Julia. In the next video, we will get started and set up our first agent-based model.